suppose, see, one of my student is very basics in the Hadoop. He asked me, I didn't able to understand actually what is Hadoop, what I'm going to do. Then I have given him a simple a text file, a notepad file, which is in Windows. I told him just open that file. Then he tried to double click that notepad file. Then actually the file contains bulk amount of data. So in Windows, in his machine, he spent approximately 10 to 12 minutes open that notepad. Then I told, just wait for a minute. I have copied the file to the Hadoop file system. I have shown him the content of the file in less than 3 minutes. Right. See, this is how we are going to work with the bulk amount of data. It's a simple example. That's everyone, you and me, we are how we are working with data. Right. So the big data is, it is a huge amount of data which is too large to process using your traditional methods. Right. So now what we had having, suppose we can see the clients like healthcare, retail, automobile, manufacturing. So they have the clients, their users will be like a many number of users, some lakhs of users are there. Right. See, maintaining the data, right, everybody will maintain the data, but when it is coming to the giving a personalization to every client, see, I can able to identify, I can able to understand the requirement of every user. Right. So a personalization, if you want to give it to your user, your customer, so there is a one programming right now in the market, that's a big data. We know that suppose if a client is trying to implement a new project, right, so in the client's perspective, he looks for the two things. One is high availability, and the second one is the cost. So the cost for the implementing the new project, and how much high availability you're giving for this environment. Right, the two things. Now see here. So now we have seen, like, so the big data is, it's a huge amount of data, and the data can be any type of data. Either it can be structured, or it can be unstructured, or it can be semi-structured, or you can say loosely structured data. Right. So what is a structured data? Suppose you are having the data in some rows and columns, like it's a table in RDBMS is an example for structured data. Then what is unstructured data? Yeah, unstructured data is, it's a plain text file, the flat files. The data is written into a text file. Now we are going to analyze the data by taking the data from the a flat file is an example for unstructured data. Then loosely structured data. So what is a loosely structured data? The structure is defined, right, but it's not mandatory, you need to follow the structure. So that kind of data is known as loosely structured data. So now what we are going, so we are working with any kind of data, and we are working with any size of data. Here you can say huge amount. How much huge amount? It's in terabytes of data, or it is in petabytes of data, or it is in exabytes of data. The coming to the data size, right? So here we are going to with terabytes or petabytes or exabytes of data into the coming consideration of the size and the type of the data. So it can be any type. We can able to work with any kind of data. Either it can be a structure, right, or unstructured, or loosely. So in other words, we can say if the data is written into the JSON data, or if the data is written as an XML file, or if the data written is an Excel sheet, or the data which is in a CSV file, right? Suppose if your data is available in your production database, or if your data is traveling through the servers, or if your data is available somewhere into the physical system in a disk, right? So whatever the data it is, wherever the data it is, what kind of the data it is, right? The best thing, we are going to work with the big data. So as of now, what is a big data is, it's a huge amount of data, and it's a structured, unstructured, semi-structured data. Right, fine, okay, Ajay, so we have the data. Now what to do with the data? Right, how, why the big data, what we are going to do with the big data, and actually why we have a Hadoop. Right, see here, right? So this is the data, and see the data can be, it's a petabytes and exabytes of data, and millions and billions of people are there. So there are billions or the trillions of records are there. So the data is structured, or often it's a distributed data. So every transaction is written by a timestamp is specified, right? So now it's a different types of data we are having. Now we, with this big data, we are going to apply the big data analytics, right? What we are going to do now, we are going to apply the big data analytics, so that a business can able to take a better business decision. A client or a business can able to identify, he can able to predict the changes. A business or a client can able to identify the new opportunities. So once the data which we are, a client or business thinks that it is a junk data, spam data, unwanted data which is going to be deleted, now this data becomes more useful for a business to take a decision, right? So now see here, we are digging the data. How much data we are digging? The data we are digging in the form of terabytes of data. That much of the data we are digging to retrieve a small result, right? Have, I'll give you one example here. Here I'll take an example of you can say the Flipkart, it's an e-commerce client. You can say Best Buy or anything, Walmart, the client. Suppose they have the batch processing, right? So OLTP data, not OLTP, OLAP data, right? So every day, so the today's transaction, the today transaction means what? The data which started today night sometime 0000 m to next day 11:59, the same day 11:59:00 m, right? Some data, today's data. So I'm saying that I have a file. The file name is pradinfo.txt, right? So it's an unstructured data, right? So it's a flat file, right? The file name is pradinfo.txt, right? Now I'm going to teach you, I'm going to show you, right? Why, what are the big data analytics we are going to write on the data, how a business or how a client will able to identify the requirements of a customer as well as requirements of their clients, right? So this is one example. The client here I'm taking is an e-commerce based client. Okay, I have a file pradinfo.txt. Now this file contains the users who visited the products today in Amazon or the Flipkart or eBay or Best Buy or Walmart, right? So these are all the e-commerce clients, right? So username is there, and the product, right? Visited products, the product name we have, and price of the product, and time of the product. So some data we are having like this: username and the product which he visited, and the price of the product, and at what time we have visited. So you take Ajay is a user, right? See, he visited some iPhone 6, right? Its price, it's some amount of rupees in INR, right? And the time, so sometime he visited the product, right? Like this, the text file contains all the records, right? All the entries. So whoever the user who visited the products, their name is written into this file, right? Consider now this file contains total 7,50,000 entries, that is 7,50,000 records are there, right? So do we have any limit that a user has to visit the product only once? No, a user can visit the product any number of times, correct? So now whenever you visit a product, your name is written into this file. In this example, suppose Ajay is a user, he visited the product 100 times, he visited the product 100 times. Now that is his name is written into this file 100 times, correct? Now, so it's a today's data is completed. At the end of the day, your team manager or your project manager call you, yeah, Mr. My Hadoop developer. See, now I want to generate a report. See, find out. So the query which we are writing is find out how many customers or can say users visited the product iPhone 6, right? So this is the query, right? This is the job or this is the report you have to generate, right? How many users visited the iPhone 6? Now you have to count the what is the product name in the table in the data set. It's iPhone 6 which you are looking. Now for each iPhone 6, how many number of users are there? You have to count him as a one user, right? Ajay is a one user in the one entry, then next user. So you have to count. When you're counting like this, now, in this data, Ajay is visited the product 75 times or some 100 times. That is, his name is written 100 times in the data set. So, when you're counting the total number of users who visited the product, so can you count Ajay as a one user or can you count Ajay as a 100 users? His name is written into the 100 times in the data set. Can you count him as an 100 users? No. If you count him as a 100 users, so this is a wrong calculation, right? You will remain more stock in your inventory, but the products which you are going to sell is very much less because you have counted 100 number of users. One user actually is Ajay is a one user, but visited the product 100 times. So even though his name exists multiple times in the data set, we should consider him as only one user, right? Suppose if you are going to write another query, how many times each user visited iPhone 6. So this is another query. Now, so what you have to count him now? How many times? In this example, Ajay is a user. He visited the product 100 times. Right, so in the first example we are counting Ajay as a one user. In the second example we are taking Ajay as a 100 users, right? So these are the different types of analytics which we are going to work with the big data, right? Now see here, finally your client wants, yes, now I just want to know how many users are going to buy iPhone 6 in the coming days, right? Now take this data and analyze the data and tell me like how many products are going to be sold tomorrow and after tomorrow in the coming days and this week. So this is the question will be given to you. Now you have to go for the predictive analysis. You have to identify the changes, right? You have to identify the people. Now see, a user visited the product 100 times means you can identify that he's going to buy the product, right? Suppose a user comes to the platform Amazon, I searched in the description iPhone 6, have seen the description about the product, some time he spent with the product, have seen the reviews, right? So he visited the product 5 to 6 times, then he searched in the Google about the same iPhone 6. Yes, you can say that yes, he's going to be interested, maybe he will buy. A user comes to Amazon, he's searching for the some other product, but in the left side he find iPhone 6, he clicked the product, he have seen the product for a minute, then he shifted, he navigated to another product. Is he going to buy? Right? Now see, based upon this, like based upon the analyzing the data like this, now you should suggest them, right? You should able to identify them. So these are the analytics which we are going to apply on the big data, right? So these are the big data analytics. These are the queries which you are going to write by targeting the big data. So what you have to identify here, what you have to observe here, see here, I'm not going to analyze the data which is a structured data. Here the data is written into a text file, right? And I'm writing these queries, I'm writing the programs by targeting the data which is a plain text file, which is unstructured data. Unstructured data leads to always inconsistent data. Unstructured data leads to incorrect data. Unstructured data leads to inaccurate data, and we are taking the data into the consideration and we target the data and we are writing the queries by going through the unstructured data. So this is how we are going to work the big data analytics. Suppose I'll give you another example. It's a telecom. right? So we know that in India we have MNPs there. Suppose that it means you can switch, right? So if you're not satisfied with the network, which is right, the features or anything, so immediately you can able to shift right now. So your data science team is trying to introduce a new plan. See here, we have two kinds of users are there. One user is X who messages frequently or every day. Y is a user who travels every day, right? So there are the two users, one is X and other one is a Y. X messages an every day, Y travels an every day. Now your data science team, right, introduced a new plan, right? Here, observe here, whenever you have introduced a new plan, you have to suggest this plan to the users who are going to get benefit it one, right? Suppose if the plan is related to messaging, so you have, if you have to suggest this new plan to the user X, so that X can get benefit with this plan and X will get benefit with, and the client or your business also will get the benefit. But suppose you have introduced a new plan which is related to messaging, but you have suggested it to the user Y. Right? Actually, Y is expecting a roaming plan from you, but you have suggested him a message plan. Right? So now see here. So in this case, whether the your customer is not going to get benefit with this new plan, and you are also not getting any benefit with this new plan. Suppose if you can able to identify, if you can able to understand the requirements of every user, right? It's a kind of personalization. You know that what X wants, if you know what Y wants, so based upon their usage, based upon their usage history, you can able to suggest him the relevant plan, right? Actually what he's expecting from a client, what he's expecting from a business, you can provide the same to him. So like in this case, now you should able to identify the requirements of every user. That means you can able to identify, you can able to analyze the all the customers activities, right? So they are the going to be analytics, which are the big data analytics. So fine, you can say, right, Ajay, so we have the big data analytics. So how it's going to work with? So previously we used to have a DBMS, RDBMS, right? So writing an RDBMS means what? RDBMS is a concept, right? It's a theoretical concept which we are going to implement this RDBMS in Oracle, or you can say MySQL, or you can say SQL Server, or you can use DB to HQL, right? So RDBMS is a concept. So the implementation of RDBMS is done in right, Oracle MySQL kind of tools. Now here the big data is theoretical implementation, right? So now we can apply this big data analytics into the frameworks. Like so, what we have SAP HANA is that you can use Oracle Exadata is that you can have, we have Teradata is that, and finally here I'll take for example Hadoop from the Apache is that, right? Where we can write, where we can apply the big data analytics. Now, if you use SAP HANA, or if you are going to Oracle's Exadata, or if it is a Teradata, the first thing is you need to have storage to store this data, right? You need an hardware you need to buy, right? So how much the cost of SAP HANA, right? It's they are the costlier storage machines you need to have, and then application engine, the programming tool, right? So the application engine, SAP HANA will have HANA appliances. You have to have that one, and then you need to buy the license, and then you have to pay for the support. And the same thing for the Oracle Exadata, and same thing for the Teradata. You should have an hardware, storage machines to store the data, and you should have an application engine to write the queries to run the jobs. It's a programming, and then you have to pay for the license and you have to pay for the support. Now it's same thing for the Oracle Exadata, and it's the same for the Teradata. Now see, this is what we have in the session, what we are discussing, that is Hadoop, right? So the Hadoop, now it supports hardware in the sense it's a commodity hardware. What is a commodity hardware? Commodity hardware are the reusable machines. Commodity hardware are the inexpensive machines. Are see when if you want to implement the Hadoop, we are not suggesting you go and buy the expensive storage machines to store the data. You go and buy the inexpensive machine. You know that the difference between a costlier device storage machine and a cheap inexpensive machine, right? If it is an inexpensive machine, storage machine, we can expect the failure any time, right? It goes down, but no issue. If your particular node machine goes down, it doesn't make any sense, any difference in your job processing. So we are suggesting you go and buy the inexpensive storage machines. That is a commodity hardware. So commodity hardware are the reusable machines. Commodity hardware are the inexpensive storage machines. Now Hadoop uses application engine, right? C language you can use to work with the Hadoop. C is open source and freeware, right? C++ you can use to work with the Hadoop. It's open source and freeware. Java you can use to work with the Hadoop. It is open source and freeware. You can use Python. It's again open source and freeware. See now, right? So these all are the open source and freeware, the application engine which we are using in Hadoop. You can say, yeah, Ajay, but I'm new to the programming. I don't know any of these things. Right now, Hadoop is providing, Apache is providing two components, that is Hive and other one is Pig. Right now, you learn, we work with these tools as an application engine to work with the big data. License, this Hadoop is, the license is given by the Apache, which is open source, right, which is a freeware. You're not paying for the license. See now, coming to, see, I told, right? So what a client always prefers, the cost and high availability. Now how much you are investing here, right? It's very much less. One thing is coming to the hardware, we are using existing infrastructure, or we are using commodity hardware. And coming to the application engine, we are using all the open source tools, and the license is a freeware, right? But the coming to the support, right? So Apache is not providing the support, right? So you have to approach public forums to get the support for your issues, right? So this is Hadoop from the Apache. But see, you sometimes it's difficult for me to configure because your client doesn't want to go for a separate administrative team, right? So now he's looking for someone to configure the cluster, to configure the Hadoop. Then you can buy the Hadoop from the vendors, right? So if you want to use Hadoop, right, with a less cost, don't want to buy, then use Hadoop from the Apache. Or if you are looking for someone to support you, if you're looking for someone to configure, then buy the Hadoop from the vendors. Buy the Hadoop, or you can say vendors, or you can say these are the distributors. So Hadoop is available from the Cloudera. Hadoop is available from the Hortonworks, and Hadoop is available from the Mapper. Apart from that, we have the different Hadoops are there. So Hadoop is available from the Pentaho is there, Teradata Hadoop is there right now. So the last one they have released, and Hadoop is available from the Intel. Hadoop its own is available from the IBM, right? But so these are the most right. So the first in the market is a Cloudera, captured more number of clients, and then it's a Hortonworks and the Mapper we are having. So the Hadoop is available from the Cloudera, which they are giving Hadoop in the form of CDH, right? So the recent new version is CDH 5.0 with Hadoop 2.70 is available, and the Hortonworks they are giving Hadoop in the form of SDP, right? So with the new version of SDP 2.0 with the Hadoop 2.7.0, and the mapper, so we are get the three different versions in the mapper, that is M3, M5, M7. Right. So the same Hadoop is available in the Cloudera. So Hadoop is available in the Hortonworks. Hadoop is available in a Mapper. So they are giving. So don't think that again this Hadoop is different. See, I'll give you in a simple words. right? The movie is same, but the theaters which we are playing is different. Here the movie is a Hadoop, right? So the same movie we are playing in one theater, that's a cloud era. It's the same movie which you are playing in another theater, Hatton Works. It's the same movie which we are playing in the Mapper. But where the difference comes in the environment, the difference comes in the features, the difference comes within the added features which they are providing. But initially, whatever we are saying, it's a Hadoop, which is it's HDFS and the map reduce and the core programming, the core concepts, it is the same in all the Hadoop distributions. We are using Hadoop 2.7 in the cloud era, the same Hadoop 2.7 we use in the Hortonworks, the same Hadoop 2.7 we can use in the map art. So we won't find the much difference while writing the program, while writing the jobs, right? The difference comes in the features, the difference comes in the support cost, right? Implementation cost based upon that one. So the difference comes in the components which they are providing. So based on that, so we have the difference. Okay, so here I have a question
Uh,
from Madhu.
I, I have a question here.
Yes.
Uh, my friend, I would like to know the system requirements, you mentioned about hardware components and stuff,
Okay.
and is it what is the RAM size and what is the, system configurations?
Yes,
Does
yes.
it different? Is there any difference between the distributor provided, Hadoop software, Hadoop,
Wait.
engine, and the other ones? Can you please cover that?
Okay, fine. Right, we'll see that. See, coming to the hardware and the infrastructure, right? So which one to provide? See, just a second. See, we have see generally when you want to configure the Hadoop, right? See, now based upon your data size, how much data you have to process and how you are getting the data. So generally, suppose if you are collecting the data from your production database, or if you are collecting the data from the web server, and how much data you are collecting that, so based on that one you should calculate the your system requirements. Exactly, I can't tell you, so this will be your system requirements based upon how much data you are using, so how much data you have to process. So we should have a calculation based on that. What we should have to calculate, the first thing is how much memory you need to make available for the name node. After that we'll decide how much memory it for the secondary name node, and how much for the high availability node, how much for the data nodes. So before that you should know that. See, generally, see, so these are the configuration, right? How to configure. So this is in the chapter 3. I'm going to teach you about, so how to configure the Hadoop cluster, and how to, right, identify, right? So what we need to configure in the name node. So what will be the system requirements, right? How to calculate how much memory you need to configure for the name node, right? How much you need to configure for the data nodes switches, right? See, I'm going to show you. This is things which we are going to discuss in the chapter 3.
Then fine. That's absolutely great. And I just want to, since you mentioned out there, that's why I just want to make sure you put some light on that. That's
Yeah.
why I just asked you.
Yes,
Thank you
that's,
on that.
yeah. We have in the chapter 3, that's a Hadoop cluster specification. So there I'm going to reach it because it's a time consuming, and this is an interactive session, right? So I can't go a little
Carry on.
bit dig it on deep on that one, but I'm teach you that one. The each system, so how to calculate the cluster size, how to calculate the memory for the name node, because in fact name node is a primary memory, so we should have a calculation that one. How much you need to go for the name node, that we'll see. Okay, now see here. So
Uh,
these are the Hadoop is distributed. Now Hadoop is available from the Cloudera, Hortonworks, and Mapper. Here we have one difference. Now both the development part and admin part, right? In the Cloudera, we use SDFS, right? It's a file system. We'll see what is this SDFS later. The physical file system is SDFS, and we have Cloudera Manager is there for the administrative purpose. Okay, so we use Cloudera Manager to admin the Cloudera cluster. And if you're using Hortonworks, right, so Hortonworks is using a file system SDFS, so no difference, and they use Ambari, right, to administer the Hortonworks cluster. And if it is a mapper, see the difference here. Mapper is not using SDFS. They have not really done SDFS. They have their own file system, so it's a mapper file system. They, instead of Hadoop, they are using mapper file system. So they have a mapper control system to administer the Hadoop cluster, right? So now the physical data is available in SDFS, right? As a file system, the administrative can be done in the tool Ambari, right? The Cloudera, we have a physical file system SDFS, and the administration can be done in the Cloudera manager. And if it is a mapper using mapper file system, and we can administration can be done, right? Is that's a mapper control system MCL we use. Okay, now see here, coming to the hardware, coming to the implementation of this one, why Hadoop is getting that much of famous, and what about Hadoop in the coming days? I'll give you one simple example here. Hadoop can be Hadoop. We cannot say it's exactly it's a programming tool, or we cannot say exactly it's an analytics tool. We cannot say only we need an infrastructure for this. We can use Hadoop anyway how you want. One thing is, you want to go for an infrastructure, you want to configure the cluster, you can use this one. You want to use Hadoop, you want to Hadoop integrate into your existing infrastructure, we can able to integrate. That is, in the sense, we can use Hadoop in SAP HANA, we can use Hadoop in a Teradata, we can run Hadoop as a service. Okay, we can able to run Hadoop as a service. And suppose you don't want to go for the infrastructure, we can dump the Hadoop into the cloud. Now we can able to start writing the jobs, right? Don't buy the hardware, don't go for the infrastructure, take a storage in the cloud, take a rent of some storage in the cloud, dump all your data, and then write map reduce jobs by targeting the data, right? So we have Amazon EC2 cluster is there, Amazon S3 is there, Karma Sphere is there, and you can use Windows Azure is there. So we can use any cloud where we are going to store the data and we are using the process. So that is either you are an infrastructure or you don't have the infrastructure, right? So that is the advantage. So now every client in the coming days, because being an individual, suppose if I want to buy a product, so then what I'll do, I'll go through some reviews, I'll ask my colleagues, I'll ask my friends, then I'll collect some feedback. Based on that one, I'll decide whether to buy that one or not. Being an individual, right? So this is analytics which I'm doing. I have a 1 TB hard disk in my laptop, I have 1 TB hard disk in one desk, my desktop. I'm using 64 GB in my mobile, then I'm using some cloud in the Google, I'm using cloud in my iStore, I'm using cloud in Flickr. See, being an individual, how much data I'm having. And I'll tell you, in the coming days, every client will have Hadoop in their environment. Hadoop is like, see here, right? So till now, we have habituated to the three-tier architecture program, right? Every of our project is a client we have, and we have a server here, and it's a database. It's a client and server architecture, and the client is going to connect to the server, and from the server to database. So the processing is done from the server side. The data is available in the database. Now, if a client is using Hadoop, see here, if the client is implementing Hadoop for his project. Yes, Madhu, just a second, I'll let you know that. Right? So this is your existing three-tier architecture. Correct. Now, so if a client is trying to implement Hadoop, means don't think that he's going to migrate. right? Now this Hadoop is an added infrastructure for this existing infrastructure, right? So this is your production database. Now, so here, coming to the definition of Hadoop, right? So can anyone define what is Hadoop? Right. See, I'll tell in two sentences. Hadoop is a distributed data processing system. Right. So what is Hadoop? Hadoop is a distributed data processing system. See, observe here the data. The data means the big data. The data which we are having terabytes, petabytes, and exabytes of data. Now what we are doing, we are distributing this data where Hadoop supports a concept called JBOD. What is a JBOD? JBOD stands for just bunch of disks. Okay, JBOD stands for just a bunch of disks. Now we have a bunch of disks are available. Now the data is going to be distributed to a bunch of disks. Okay, after that we are going to process the data which is available in this bunch of disks. Okay, so what is a Hadoop now? Hadoop is a distributed data processing system, and I'll define Hadoop is a combination of SDFS and MapReduce. See here, suppose you have Windows, right? You have bought a new machine, new desktop. Now first what you have to do, you have to install an operating system. Either it can be a Windows or it can be a Linux. If you install Windows, right, you'll get a file system called NTFS file system. Now the files which you want to work with, right, physically the files are available into the operating system. That is, suppose if I want to play a song, then what we have to do, we have to copy the song. We should make the song available into the C drive, D drive, E drive somewhere. After that you have to double click the song, then it will be played in a player. Correct? That is, now when you configure an operating system, you'll get a file system. On top of the file system, we are writing our files physically. The same thing now. So if you want to configure Hadoop, now we should have an operating system to be installed in the disk. After that, on top of the operating system, we install the Hadoop. Right now, so in the first, we have operating system. Either it can be a Windows or it can be a Linux you have configured. Okay, and in the top of this, we install Hadoop. Okay, so here we have Hadoop. Now so this is a local file system, this is a Windows file system, and this is a Hadoop file system. Now if it is a Linux machine, so this is a Linux file system, and the above one is a Hadoop file system. So the Linux file system, we use some ex1 ex2 file system, right? If it is a Hadoop file system, what we'll do now, we use SDFS as a file system, right? So this is SDFS file system, and this is line in the operating system level. So this operating system and is SDFS file system. Now we can able to copy a file from the local to SDFS, SDFS to local file, means operating system to Hadoop file system, Hadoop to operating system. That is, whenever you configure Hadoop, we'll get a file system. That file system is SDFS. SDFS stands for Hadoop Distributed File System. Now, so the data which you want to process, see in this example, the file which is a prod underscore info, right? We should make this file available into the SDFS, right? After that, we'll write the MapReduce jobs. Now it's a MapReduce, or now the MapReduce is replaced with a yard, right? Otherwise it's a MapReduce or it is a yard. right? So Hadoop is a combination of SDFS and YAR. So it's a before 2.0 SDFS plus MapReduce. After 2.0 it is SDFS plus YAR, right? So this is before 2.0 Hadoop version, and this is now Hadoop after 2.0. It is SDFS plus YAR, right? So it's mandatory. It's not mandated that whether you have a MapReduce or not. But Hadoop before 2.0, the jobs which you are running should be a MapReduce jobs. So what is a MapReduce, right? So again, I'll give one example, right? One of my colleague, he asked me, yeah, Ajay, how to write a MapReduce program? Please write a MapReduce program. Then I wrote program in C language. No, Ajay, I want to write a MapReduce program. Then I wrote a MapReduce in Java. Again, he's saying, no, Ajay, you have to write a MapReduce program. Then I just raised him question. Do you know OOPS? Yes, I know OOPS. Then I told him to write a OOPS program. Then again, he's writing this OOPS program in C++. Then I asked the question, why you're writing OOPS in C++? Yes, that's the answer now. Oops is a concept where we can write into the C++ and Java. Here the MapReduce is a concept where we can write this MapReduce into the any application engine which we are using for the Hadoop, that is a Hive or the Pig or the C or the C++, Java or the Python. Right now, so what is a MapReduce? MapReduce is a concept which we can best analyze the data, which we can best shuffle the data, which we can best sort the data. So MapReduce is a concept where we can implement this MapReduce concept in C language. We can implement this MapReduce in C++. We can implement this MapReduce in Java. We can implement this MapReduce in Python. So writing a MapReduce program is writing a C or writing a C++, writing a Java or writing a Python. Like, so these are the programs. You don't know this, then learn Hive, then learn Pig, right? So then we can able to write the MapReduce. Hive we don't write MapReduce. Hive programs are taken by the MapReduce. Pig we can able to write the MapReduce. That we'll see the difference between Hive and Pig in the coming sessions. Okay, so now, so Hadoop supports SDFS and R, and we have a bunch of disks are available. Right now, see, we have some bunch of disks are available like this. Okay, so we call these are the some data nodes where we have the data physically available, right? So Hadoop will have bunch of disks are distributed into some data nodes. So these are the data nodes, right? So what we are doing now, these data nodes together configured as these are bunch of disks as configured as a nodes, and see this bunch sum of nodes, few of nodes configured as a rack, right? So we'll see this class specification in the chapter 3. As of now, just remember, so Hadoop just bunch of disks. Now the bunch of disks are configured as the data nodes. So this is a one disk, this is another disk, this is another disk. When we install Hadoop, so we'll have SDFS in this one. So in this data node we have SDFS. Now in this data node we have SDFS, right? And in this data node we have SDFS available, right? So we have configured Hadoop in an operating system, right? So below we have an operating system, right? Either it can be a Windows or it can be a Linux, right? So on top of the Linux operating system, I have configured the Hadoop. So this is the Linux machine, right? In the top of the Linux, I have configured Hadoop. So when you get the configure the Hadoop, we'll get the file system. SDFS is a file system. Now, so we have the data nodes and the reference. Now, which data node contains which data will be written to a reference node, that is a name node, right? We'll see this name nodes and data nodes, the we'll see in the later sessions. As of now, remember that, so your actual data is written into the data nodes, right? So in this case, the prodinfo.txt, right, the file which we are going to process now, the file, the content of the file prodinfo.txt is written into the data nodes. Now which data node contains which data is written into the name node, right? So we have some extra node is there, which is configured as secondary name node, right, where we have a snapshot of this name node is available. and to make the cluster high availability, we configured some another node which we are configuring it as a high availability node, or you can say shared node, or you can say journal node, anything, right? So to make the cluster high availability, right? So we have like this, right? Now name node, so the snapshot of the name node is written to the secondary name node, and the same duplicate writes are written into the HA node, right? We'll see these things in the coming sessions, right? As of now, our actual data, the file which we are going to write, the data which we are going to process, which we are going to apply the analytics, that is written into the data nodes. Now this reference of the data, the index of the data, metadata, is written into the name node. Now see here, right? What we are discussing now, where suppose if your client wants to implement Hadoop, so I told is migrating to Hadoop means is not completely migrating. Is implementing Hadoop means is not migrating. So what he'll do now? So consider, so this is your production database, and every day you're getting the 500 GB to your production database. Now, so that means today 500 GB, so tomorrow becomes 1 terabyte of data. So like in a month you'll get 15 terabytes of data, and it's difficult for us to process it with a DBMS. Suppose today I have 500 GB of data, but if I want to analyze, I can able to analyze, but it takes some 5 to 6 hours I need to spend to generate a report. Correct. So now what we'll do, so we'll move the data from this production database to the Hadoop cluster. That is, we have a component called Scoop. We use Hadoop component Scoop. With this Scoop, we can able to import the data. We can able to export the data between SDFS to RDBMS and RDBMS to SDFS. So Scoop is under the umbrella of Apache. Scoop is a Apache sub-project. We use a Scoop to import the data from the DBMS, RDBMS to Hadoop cluster. So this is one way we get the data into the Hadoop cluster to process it. Right now, what your client's data is available in the production database, he will move the data to the SDFS, and then being a Hadoop developer, we analyze the data. Suppose now all the client doesn't have the database. See, you can say the Google, YouTube, right? So they, for them, maintaining the data in a database difficult, right? So the data is traveling through the servers. If your data is available in a server, or if your data is moving through the servers, or your configure network attached storages, you are having a scribe middle types. Now I'm going to configure an agent, right? The agent, in the sense, it's a process. Now this agent resides in the server. I told this agent, yes Mr. Agent, you just reside in the server, right? So now this agent will reside in the server. When the data is coming to the server, this agent will collect the data from the server and loads the data into SDFS. He loads the data into SDFS. Now we configure this agent with a component called Flume. Flume is one of Hadoop subproject, where if your data is available in the servers, where your data is traveling to the servers, we configure Flume agent. So this Flume agent will collect the data from the servers, and he will sync the data into the SDFS. So this is one way we'll get the data from a client to the Hadoop cluster. Now, right? Otherwise, if you have the data is available into the operating system level, we can able to copy the file from your operating system to SDFS file system. Right? We can perform both SDFS to local file system, operating system file system, or operating system file system to SDFS. Right? One way we load the data with a Scoop, other way we use a Flume, or we can use Linux operating system level files we can copy to the cluster, or we can able to configure FTP protocol to copy the files. We can use FTP, right? Or we can use web-based DFS, right? It's a right. So these are the different ways we make the data available into the cluster. After that, now what we are doing, we are passing the data with data processing tools, right? Here now you can use Hive and Peak to process your data, right? After data processing, then what to do, right? We cannot give the direct output as a to the cluster, your customer, right? Your client. So we have to generate a report. We need to generate a beautiful visualizations, right? So the visualizations purpose, now we move the data from this data processing to the visualization tools. So what are the visualization tools now? Here we have W is there, right? You can use quick views, right? You can use Jasper reports, or you can use Zoom charts, or we have a Pentaho integration is there, right? So we have the different reporting tools are there. Now move the data from Hive data processing tools to the reporting tools. Now, after that, I want to store the data itself in the cluster. Yes, if you want to store the data, then we have a NoSQL is available. See here, now it's a production database, correct? Where you have the data, structured data. The fields are enabled with a primary key. Now, I want to get the same data into the SDFS with the same keys are enabled by the primary key. Then we can able to move the data from the production database to the NoSQL. So here we have NoSQL to store the data, which is works as a database, that is HBase we are having, or you can use MongoDB, right? So we have a CouchDB, or if you are using Amazon cluster, it's a DynamoDB. So we have the different NoSQL databases are there. There. So now we can able to store the data into the NoSQL databases, right? So from this, once the processing is done, we can able to store the data. Otherwise, from the SDFS, we can able to store the data into the HBase, right? Now, being a Hadoop developer, your job role, right? What you have to work, right? What is the difference between Hadoop developer and Hadoop analyst? Now, as a Hadoop developer, your responsibility comes into the data collection team to collect the data from the various data resources. After that, to process the data with a various data processing tools. That is, being a Hadoop developer, in the collection team, you have to work the Flumes, Cube, right? SDFS, Hive, Pig. Suppose if you are working, if your job role is Hadoop analyst, right? Then we use how to analyze the data with Hive and Pig. Then you should know how to generate the visualizations from the data Hive and Pig, right? So this is the difference between Hadoop developer and Hadoop analyst. So Hadoop developer, so your job role comes into the Hadoop data collection team as well as data processing team, and Hadoop analyst, so you should be in a data visualization. So we use Hive and Pig, and we process the data from Hive and Pig to the visualization tools, and then we generate the beautiful reports. Now, if you're looking for a database site, so we have a HBase developer is there. We have a MongoDB developer, CouchDB. Suppose we have a Java developer. How much work we should know? DDL, DML operations, we should know. That's it. Now, if you want to write something programmatically, then we have a separate PLSQL developer is there. Now we send this job to the PLSQL developer. He write that. But being a Java developer, what you should know? You should know like Java and how to connect to the database and how to retrieve the data, how to perform update, insertion, drop. We should know that. The same thing now, being a Hadoop developer, the CRUD operations, create, update, read. So these we should know that. But the programming of HBase, we have a separate HBase developer is there. MongoDB, separate MongoDB developer is there. CouchDB, so there is a separate CouchDB developer is there. So these are the databases which we use in a Hadoop cluster, right? So this is the difference between Hadoop developer, Hadoop analyst, HBase developer. Okay, now, so coming to my training content now. So this is my training content.
Ajay, if you can I ask you a question?
Yes.
This is Prasad again. Yeah, like so far, whatever you covered is purely talking about, correct me if I'm wrong, like, sequential or, structured, let me put it as structured and semi-structured kind of data
Yes.
formats.
Yes.
But if I have to process the unstructured format, unstructured data
Yes.
stuff, so do we have any kind of processing applications like
Y-
Hive, something like that?
yes.
I just have that question I have. It's been
Okay.
long, so that just
Okay.
asking you.
Okay, fine. See, right now, see, this is my yeah. I'll let you know that in this one, right? So this is basics about how what is a big data. It's a chapter one we are having. Now, this is the chapter 2, right? So, this is different Hadoop distributions, how we have Hadoop from the cloud era, how to use Hadoop from the Hortonworks, how to use Hadoop in a mapper, how to work the Hue, how to work the cloud era manager. So, what is the HDP, how we have the mapper distribution. So, this I'm going to teach in the chapter 2. It's a very much basics in the chapter 1 and chapter 2, right? Now, our actual discussion starts from chapter 3. Here, I'm going to teach you about the SDFS file system. So how this SDF is designed, right? So what are the Hadoop daemons are there? How we have the master and slave architecture? So what are the configuration files? How we load the data different ways to into the SDFS? How we access SDFS through Hadoop API? File system shell, how we access the data with the Java API. So this is we'll see in the chapter 3. Now in the chapter right in the chapter 4, right, we have is Hadoop admin is there, right? How much admin a developer requires? Okay, so how much admin a developer requires, I have added those things into this chapter 4. Right here I'm going to teach you, like, so what are the different ways how to configure the Hadoop cluster, how to install the different ways, and what are the post installation steps, right? How we able to read the data, how we make the cluster high available 24 by 7, right? How to balance the cluster, right? How to check the Hadoop file system health, right? So this is I'm going to teach you in the chapter 4. Right, in the chapter 5 I'm going to teach you about how to work this cube, right? So I'm going to teach you what is this cube, how to connect to the different databases, how to retrieve the data from the different databases, like how to perform importing and exporting the data, importing from an RDBMS, either it can be Teradata, or it can be Oracle, or it can be a MySQL server, or it can be a H2O, any database, RDBMS, right? How we import the data from the RDBMS to Hadoop, that is SDFS. I'll show you practically importing the data to the SDFS, importing the data to the Hive, importing the data to the HBase, importing the complete the data, import some specific data based upon some specific conditions, importing the data to the HBase with some specific conditions, importing the data with the primary key enabled data, importing the data which is not enabled to primary key. So I'm going to show you these things in the chapter 4. See, I'm going see all my sessions are practical oriented sessions. It's not like taking a PPT and explaining directly from the PPT. No, I'll show you everything by executing in my session, right? My sessions are complete practical oriented sessions. We'll work here, we'll get the errors, we'll trace the errors, we'll debug the errors. So the sessions are practical oriented sessions, and I'll show you the complete working with a cube, right? Again, in the chapter 5, it is Hive programming. Now I'm going to teach you, right, what is a Hive, how we load the data, what is Hive partitions, Hive buckets. Now you ask me the question, right? We have different formats of the data. Suppose you have XML data is there, then here in the Hive I am teach you, I'll show you, all right, how to process the data which is in XML format, how to process the data which is in JSON format, right? So this is I'm going to teach you in the chapter 5. Either it can be the data which is in RDBMS, or the data which is in a flat file, or the data which is serialized from the some external resources, or you can say the JSON data, or it can be an XML data. So I'll cover those things in this chapter 5, right? So right now this Hive is going to be depreciated with a new beeline. So I have teach you how to use a beeline and what is a BSQL, right? So this is Hive, right? I'm going to teach you, right, everything, right? So different ways and different types of the data. Fine. uh, is it okay? Uh, your question is cleared? Madhu?
Yes, are you asking me, Ajay?
Yes. Yeah, the previous question, right?
Yeah, yeah. I got my answer. Thank you on that.
Yes, right. So it's a practical. I'll show you. So I have how we have some XML data is there, right? How to process that XML data, right? See, I have to process the XML data with the Hive. How to process the same XML data with the Pig. How to process JSON data with XML, how to process this JSON data with Pig, how to process XML data with a MapReduce, how to process JSON data with a MapReduce, right? So these are all this we are going to discuss in the session itself, right? It's a practical session, not only the theory. I'm going to show you by executing in the machine, right? So this is about Hive.
Thank you so much, Ajay.
Yeah, so what is
Thank
that?
you.
Yeah, fine. What is a distributed cache and how to be how compression, right? How about the security in Hive? How we tune the Hive jobs, and then we have. I'm going to teach you what is a beeline, how to work the beeline, right? So right in the newest version, so mostly now in the coming version, this Hive is going to be depreciated. Now we know when used to we're going to use Hive now, so we use beeline, right? I'm going to teach you what is a BSQL and beeline, right? After that, it's a chapter 7. We are going to discuss about the pig, right? I'm going to teach you what are the pig commands, right? How to process the different types of the data in a pig, how we process XML data, how we process JSON, how we process Avro data in a pig, right? So different ways to load, filter, group, join, sorting, combining, splitting, right? So these are the things which we are going to discuss in chapter 6, right? So in the chapter 7, I'm going to teach you about the MapReduce. Why MapReduce, right? How to write the MapReduce, what are the steps to write a MapReduce program, right? So how we process this MapReduce with the XML data, how we process the MapReduce with the JSON data, how we write this MapReduce option Eclipse, right? So this is I'm going to show you, right? What is the MapReduce version 1, MapReduce version 2, MapReduce version 3. We are going to discuss all the three versions, right? So this is about the MapReduce. I'm going to teach in chapter 7, and now this in the newest version. See, even the people right now not talking about much about the MapReduce. See, we are MapReduce replaced by the YARN. Now we can able to write non-MapReduce apps in YARN. Now the right, I'll next I'll teach you that one. So what are the prerequisites to learn Hadoop? Do we need Java? How much Java is required? How much MapReduce we require right now to coming with work with Hadoop, right? That I'll touch you at the end of the session, right? So I'll finish the session in 10 minutes, okay? Just 10 minutes, right? So now after that, now I'm going to teach you about the yarn. So what is yarn, how to configure yarn, how to run the jobs on yarn. So that I'm going to teach you here, right? Now here in the chapter 9, I'm going to teach you about the Impala, right? How to work the Cloudera Impala, how queries can be run fastly with the Impala programming. That's I'm going to teach you in this chapter, right? After that, I have chosen NoSQL, right? So here I have chosen MongoDB, right? You can use HBase or MongoDB as part of the NoSQL. Then I'll show you what is a MongoDB, how to work with the MongoDB, how to connect from MongoDB to Hadoop, how to get the data from the MongoDB to Hadoop, how to perform the CRUD operations, right? That I'm going to teach you as part of the MongoDB in this chapter. After that, at the end, I'm going to teach you what is HBase, right? What is HBase shell commands, how we perform the CRUD operations in HBase. So that is in the chapter 10, right? In the chapter 11, it's a zookeeper. What is a zookeeper? What is a spark? And is what is a Kafka, right? So this is chapter 11. And for your batch, for this particular batch in this month, I'm giving you the free training on the Spark. For this batch, I'll give training on Spark. You will get a new chapter, that is a Spark. Here I'm going to teach you about Spark with Scala, right? In the Spark core, we are going to discuss with Spark with Scala, and I'll teach you Spark with SQL, right? But it's difficult. Python, I won't go with the Spark with Python. I'll teach Spark with Scala, and I teach Spark with SQL, Spark SQL and Spark Scala, right? So that's we have another extra chapter will be added in this training content, right? For this particular batch, Okay, so this is about my training content. So all my sessions are practical oriented sessions. It's not like taking a PPT and explaining directly from the PPT. You'll get the practical oriented sessions, and you will be given access to the my site like this, where you can able to see the notes and recorded sessions. Every session is going to be recorded, and you will be given an access to the videos, right? Everything, right? So like suppose if you click this link, you'll get the notes, right? So notes are uploaded here, and these are the recorded sessions will be provided. Every session is going to be recorded and will be uploaded here, and you will be given access to this page. These pages are the private pages, so you need to log in with user ID to see the content, to see the videos and notes. So you'll get the notes like this. Okay, right? So my notes, right? So you'll get the notes like this, the clear detailed description including the screenshots, right? So everything what we are working, you'll get a detailed description, and how to work the commands, how to work the program, right? How to run that, everything. So I'll give you the notes. It's my own notes, right? So including the screenshots, you'll get the notes, right? So it's a scoop notes in the new version, scoop notes, right? So what is a scoop, right? How we work with the scoop commands, right? See, like this you'll get the notes for every topic. You will be given access to the notes, right? So this is notes about the complete SQL, right? The same thing you'll get the notes for Hive and Pig and everything. Okay, so any questions? Prasad, Madhu and Nuveen?
No, I'm fine. Thanks so much for your time, Ajay, and
Okay,
it's really wonderful.
okay, fine, thank you. And any other questions, please you can raise. uh, we'll have a session, it's a regular time in IST, that's a 7:30 a.m. to 8:30 a.m. So we have the sessions, right? Tomorrow 7:30 a.m. This session is going to be continued, and the duration is 40 hours, right? So it's a regular sessions, and every day it's IST 7:30 a.m. and EST it's a 10 p.m., right? So we have from tomorrow onwards the regular sessions are there. So we have sessions from 7:30 a.m. tomorrow, right? The duration is 40 hours,
Yep.
right? So
Yes.
right, so and the job support is there. If you're looking for the job support, we'll provide, but the charges are different, right? Both the training and support both are available.
It's job support in the sense, are you going to forward our resume to companies or you are
No,
going
no,
to
no, no,
train
no, no,
us
no,
on?
no, no, I'm not going to forward, so that not comes into the my role. Suppose if you're looking for, you're looking somewhere, you're working on as a Hadoop developer, you stuck up somewhere and you're unable to resolve the issue, so that you can approach us to support your issue.
Oh, okay. Uh,
Okay.
then are you going to explain on any one of the project,
Yes,
like any one of the?
yes, it's not a kind of a concept project, it's a POC. My sessions are like role based. Suppose if you're a developer, what will be your job role, right? So my examples are mostly like role based examples I'll give. So we'll have POC like a proof of concept. Suppose see, when we are working the cube, then I'll show you how to use this production data from HBase and how to process the data. The same, suppose if you are discussing about Hive, then I'll give you one example. Suppose how a Flipkart or Amazon will identify the users who purchased the product but not given the reviews, who have not who purchased and have given the reviews, who not purchased but given multiple reviews, like these examples, I'll use in the session, right? And my examples are like role based. So what will be your job roles as a Hadoop developer? So mostly I'll take that example. Suppose if it is a map reduce, I'm going to teach you. You'd say we have a true color or a just dial, then how they'll identify. So what is the top rated business in one particular area? Suppose you are listening the songs in the Ghana, right? So the most top played song this week, right? How they'll identify the map reduce, right? This kind of examples I'll give. So I'll and for every chapter we'll have a POC at the end. I'll show you, right, how to do that. So like my say,
Okay.
right, so like these are the role based sessions, right? Not like taking and say another examples. The every example is a real time based examples we'll have.
Okay. After completing the course, so we will be able to work on real-time projects.
Yes. Yes, and see, I'll tell you, the Hadoop is survivally easy, and the working environment is easier. Don't think Hadoop is a much complex programming. And I forget it. Coming to the prerequisites, so generally everybody will ask how much Java is required. Do we need Java? Right. I'm going to tell you right now. These are the days for the SQL developers. If you are good in the giants, writing the giants, so this is the prerequisite to work with the Hadoop is if you know the giants, how much you're good in the giants, right? So only the prerequisites to work with the Hadoop is the giants, not the Java. If you're looking for the Java, so only one topic in Java, that is collections in Java, is the prerequisites. Apart from that, we no need to know the Java, right? But the priority is if you know the giants, right? Any giants, either it can be RDBMS or RDBMS giants, either it can be SQL Server, MySQL. So they are the prerequisites. See, in my training content, so the most now these are the days where the priority is given for the SQL engine. Either it can be Hive or it can be a Spark or it can be a Impala. So these are all based upon the SQL engines. These are all based upon the SQL kind of programming. Right now we have given a yarn environment where we can completely skip this map reduce. Right, when we are skipping the map reduce, now we can able to write directly in the Hive. We can able to write these jobs in the Spark. We can write these jobs into the Pig without map reduce, right? You can't able to see the notes because they are the privated, right? So once all the formalities completed, then you will be given access to the notes and recorded sessions. Yes, Prasad, you're not, you don't get the access. You can't able to see the
Okay.
videos, right? So you can see a few videos in my YouTube channel, uh, right? See,
Okay.
right. So you can see how my sessions are there. Few videos are
No,
public.
for that also, I am unable to log in. That's why I'm asking you.
Right. No, you can't able to log in. They are the stick private pages. I need to provide
Oh,
for authorization for that. See, you can see
all
my
right.
YouTube channel. It's a Hadoop framework. Is my YouTube channel. So you'll have some
All right.
public videos are there. You can go through that one. Right. It's a
All
Hadoop
right. Thank you.
framework. Right. In SlideShare, you'll have some notes. So it's my SlideShare account, SlideShare.
Okay.
.NET, you can see the notes, right? It's again the user ID. My ID is Hadoop framework, right? You can follow me
Okay.
in Twitter. My Twitter is Hadoop Info One, right? My
Okay.
page is in Facebook Hadoop Info, right? So you'll
Okay.
get the updates, new things about Hadoop, right? Just follow me in the Twitter,
Mm-hmm.
okay? So Hadoop Info
Yeah.
One is my Twitter page.
Okay.
Yeah.
That's a good information.
Okay. Right. Fine. And any other questions, please? Okay, Andy, then.
Like
Yes, yeah, please.
uh, we have continuous sessions like weekends as well, Saturday, Sunday.
We have weekly 5 sessions.
Okay, it's Monday to Friday
Yes, Monday to Friday.
from 7:30 to 8:30, right?
Yes.
Okay. Like what is the process to join
Yeah,
classes?
yes, I'll give you the mails. I'll send you the links. Initially, the first three sessions are free, right? After that, you need to make the payment,
Okay.
right? You need to make the fee. Suppose after paying the fee, you will be given 3 to 4 sessions. Whether you can decide. Suppose you don't want to continue with the sessions, then I'll refund you the fee. But see, it's only the with the enough reason you should provide, and the days are 3 to 4 days after paying the fee, right? In a week, you'll be allowed. Suppose in this first week, suppose you don't want to continue with the sessions, or if you're not like with the way how the sessions are going on, then you can ask for the refund.
Okay.
Okay, so both the things.
Like in the session, no, there is no way mentioned about scheduling jobs. So, like for example, if
Yeah,
we are
Uzi,
working through,
Uzi. Yeah, Uzi. That's job scheduling can be done in Uzi because not everyone requires all the components. That's what I have not added. So how much generally we use that one, I have added. So if you want to add, so there are so many number of components are there. See, some people they'll ask me to add Cassandra. Some people they're asking me SOLR. So based upon your requirements, so then I'll teach that particular chapter to you. Okay, and
like usually not mandatory.
generally, see, it's a Uzi is a small thing because every day you're getting the data into the production database. But why should I write the same query every day? I'll schedule a job to run on specific time. So that we'll do with the Uzi. Okay,
It is a smart.
yeah, it's a simple documentation. Right. If you want to go through
Okay.
that one, so for you, I'll give you the train on that one. It's up to you,
Okay.
right? Because some people they ask me, how about SQL search? Some people they ask me Ambadi. So based on your requirement, because as of now, I have this particular month, so there are 25 students are learning Hadoop with me, right? So everyone will have their own requirements. Some people are already working developers, some people are in Java developers, few people are working as freshers, some people are working Hadoop developer, they need Cassandra. So like based upon your requirements, so I will add that into this for particularly you, right? And my
Like
sessions are like you can join multiple number of times if you're working the shifts. So whenever the batch is going on, you can join. Once you paid the fee, once you registered as student, now you can attend the sessions any number of times and any number of days too.
okay, one more question. What about the certification if you